We're talking about air quality today for several reasons. Because air quality affects public health. And because it affects public health, air quality also impacts those of us in transportation and related industries. The Environmental Protection Agency and Utah Division of Air Quality regulate our air quality. Over the years, laws and restrictions have been implemented to regulate transportation-related construction in the public interest of maintaining higher air quality standards and protecting public health. The health effects of air pollutants range from subtle issues to more obvious impacts, such as difficulty breathing, coughing, and aggravation of asthma and emphysema. In addition to the health issues, polluted air also impairs visibility. In the western U.S., the typical visual range is 60 to 90 miles, or about one-half of what it would be without haze-causing pollution. Pollution also affects the Earth's atmosphere. Greenhouse gases trap heat within the atmosphere. Although most greenhouse gas occurs naturally and helps to keep the Earth hospitable to life, it also is generated by human activities. Carbon dioxide emissions account for more than 80% of the U.S. greenhouse gas emissions. These emissions are contributing to changes in the planet's temperatures, and many scientists believe that could lead to harmful effects, such as sea level rise and changes in global weather patterns. In contrast to most criteria pollutants, emissions of greenhouse gases have been rising from all sectors. From 1990 to 2002, carbon emissions from transportation grew by almost 18%. Overall, transportation contributes approximately one-third of national carbon emissions. Substances not naturally found in the air or at greater concentrations or different location than usual are referred to as pollutants. The Clean Air Act of 1970 required the Environmental Protection Agency to establish primary and secondary national ambient air quality standards for pollutants that have been determined to affect human health and welfare. The primary standards are designed to protect against adverse health effects, while the secondary standards protect against welfare effects, such as decreased visibility. Human activity, such as the burning of fuels, happens at both mobile and stationary sources, such as smokestacks. It also comes from burning wood, dust, construction activities, agriculture, and decomposing waste. Natural sources of air pollution include dust from sandstorms, radon, volcanic activity, wildfires, and methane gas emitted by animals such as cattle, which is a specific problem for Cache County. Utah's Division of Air Quality monitors pollutants that have an immediate health effect. These are ground-level ozone, particulate matter, carbon monoxide, sulfur dioxide, and nitrogen dioxide. Currently, ground-level ozone and particulate matter pose the greatest air quality threats. In certain valleys in Utah, we frequently feel and see the effects of air pollution through inversion, when the normal temperature is inverted, so the colder air is closer to the ground. This causes the air to become more still and murky, as dust and pollutants are no longer being lifted from the surface. In cities such as Salt Lake, Logan, and Provo-Orem, this is a significant problem. In Utah, slightly more than half of the air pollution comes from motor vehicles. Industry, as well as natural sources, contribute significantly to our unhealthy air. The Division of Air Quality's Red Light, Green Light program identifies conditions as red, yellow, or green to inform Utahns of the severity of pollutant levels. There has been a reduction in certain pollutants since the inception of the Clean Air Act and the targeting of particular pollutants. For example, lead has seen a tremendous decrease since the change from gasoline with lead to unleaded gasoline. After being targeted, even with increased populations and more prevalent driving, carbon monoxide emissions have also shown a decreasing trend, and this trend is expected to continue. However, air pollution concentrations are a function of meteorology and emissions. While weather cannot be controlled, the emissions inventory can be controlled and is the focus of air quality control strategies for automobiles and industrial facilities. Air quality is a complex chemical reaction, and while we have tried certain methods to reduce other pollutants, we still have progress to make. By today's standards, Utah's air quality has gotten better. By tomorrow's standards, we need to improve. Red air quality alerts issued by the Division of Air Quality have shown alarming spikes over the years. In 2007, there were 40 Choose Clean Air Days declared by the division's air monitoring station, the most we've seen since 2004. Possible reasons for the rise in bad air days include climatic changes and changing standards. As we learn more about air quality, the standards are refined. These air quality changes require close monitoring in order to maintain and improve the quality of life in Utah. Monitoring, measures, and regulations are discussed in the accompanying Air Quality and Transportation Conformity presentation. For more information about air quality and how it relates to transportation planning, contact UDOT Planning.